Welcome you all. In this session, we are going to compare various iteration methods. Outcome. After successful completion of the session, the student would able to compare Gauss-Seidel method, Newton-Raphson method, and fast decoupled method for load flow analysis. So first, let us discuss about the Gauss-Seidel method. So for Gauss-Seidel method, more number of iterations are required compared to Newton-Raphson method, and here in Gauss-Seidel method rectangular coordinates are preferred. Here in Gauss-Seidel, time taken to perform one iteration, the computations time is much smaller. Acceleration factor used for rapid convergence. So in Gauss-Seidel we use that, whereas in Newton-Raphson method we don't have such elements. Linear convergence changes and it is uncertain. Programming task is less, more computing time. It is useful for smaller size system. Memory requirement is less. Number of iterations directly increases as the number of buses of network increases. So these are the major specifications of Gauss-Seidel method. So the computer memory requirement is less, computation time is less, and it is number of iteration increases as the number of bus increases. So this is a major drawback. It depends upon the size of system. Whereas in case of Newton-Raphson doesn't depends upon the size of system. So coming to Newton-Raphson, it is superior convergence because of quadratic convergence. It has 1:8 iteration ratio compared to Gauss-Seidel. So most of the time, within 3 to 4 iterations, you could get the result. More accurate, smaller number of iterations and number of for large size system. Yeah, fast, and the number of iteration it is independent to the number of buses. For the previous case, in case of Gauss-Seidel method, the number of iterations it purely depends upon the number of buses. But in case of Newton-Raphson, in this method, here it is independent. It doesn't depends upon the number of bus. Whatever the bus number of buses available, here the convergence is little bit faster. And again, one more thing is in Gauss-Seidel method we go for acceleration factor in order to get the convergence, but here we don't go for such factors over here. The technique is difficult and calculation involved in each iteration are more, and thus the computation time per iteration is large. And computer memory requirement is large as the elements of Jacobian matrix are to be computed in each iteration. So we have four Jacobian elements J1, J2, J3 and J4. These four elements need to be computed in each and every iterations. Programming logics is more complex in case of Newton-Raphson method. So next, let us switch to the third one, that is fast decouple method. So it is simple and more efficient. Storage of Jacobian matrix elements or 60% of Newton-Raphson method. Computation time per iteration is very less. Convergence is geometric. 2 to 5 iterations required for accurate solution. And the speed of iteration is 5 times than that of Newton-Raphson method and 2 to 3 times of Gauss-Seidel method. So these are the various significance of Gauss-Seidel, Newton-Raphson, and fast decouple iteration methods for power flow or load flow analysis. Thank you.